Hello again, this is chapter 11, and in this chapter we're going to be looking at functional programming in Groovy with closures. We'll first cover what a closure is, and then we'll use an example to build up to functional programming. And finally, we'll see how to write inline closures. So let's make a start. One of the reasons that Groovy was created was to provide the ability to add functional programming to Java. Now, in case you've not come across the term functional programming before, I'd like to spend a moment or two just explaining what this is. In Java, the basic building blocks of code are objects. We create instances of objects out of classes, and in these classes, we write methods which can take in other objects as parameters and return objects to the functions that call them. This structuring of code into objects is known as object orientation. Now, there's a lot more to object-oriented programming, as I'm sure you know, but this is just one way of thinking about how to write code. What functional programming does is it introduces a second building block which we can use in our code, as well as standard class-based objects. In Groovy, we can write a block of code a bit like a method and say that this is another type of object, and we'll call this a closure. Closures are short anonymous code blocks. Short means that most closures are at most a few lines of code. It is, I guess, the anonymous bit in this definition that's the most interesting. Anonymous means that they're not defined in our code as methods that can be called and that exist within classes, but rather as blocks of code that are objects in their own right. They can be referenced by variables and they can be passed into methods as parameters. So just as an object that we can instantiate from a class can be passed into a method, so can a closure. We can write methods that take these blocks of code as parameters to the method. Just as a method can take a string and use it, now a method can also take a code block and use it. I think the language here can be a little confusing. I keep saying blocks of code, but really I think of closures as being like methods that have the same status as objects. So they are methods that don't have to live within an object, and we don't have to instantiate an object to use this method. Now, I don't want to use the term method when describing closures, as this is going to make it very confusing. So I'm going to be sticking to the terms code block or closure, but you can think of them as fully functional methods that can be passed around our code. You might be aware, if you've done a lot of Java, that there is a similar concept in Java called anonymous inner classes. These are not as powerful as closures, and as well as being able to do more with closures, the syntax for defining them is much, much neater. If you haven't met anonymous inner classes before, don't worry, because we're not going to be using them in this course. I should also point out that Java 8, which at the time of recording this course has not yet been released, is expected to also contain some form of closures. From what I've read, the syntax is likely to be slightly different to the Groovy way of doing it, but right now these aren't available in the current released versions of Java. So back to closures in Groovy. Now, we have actually already seen some closures in action. In the last chapter on ranges and looping, we saw this line of code here. Now, I hope you remember me saying that numbers are objects in Groovy, and the number 10 we're seeing here is an integer object. Integer objects have properties and methods, and the .times method is a method on the integer object. Now, if in Eclipse I type in 10.times, you'll see that the Eclipse help is telling me it's now expecting a closure, a method or a block of code. And that's exactly what we typed in here. This print line hello map, we are in position, and whatever position it was, is a block of code. It's a valid closure. All this closure does is print something out to the console, but that's a good example of a simple closure. Well, closures are far more powerful than just blocks of code that can be provided to a looping method, so let's have a look at closures in more depth. Now, I'd like to use an example in this chapter where functional programming makes our code quicker and more efficient to create. So in this example, we're going to be working with some other developers on a system which is going to manage test scores that students have achieved in an exam. We've been told that the system needs a class called exam scores, which is going to contain lots of functionality that we're not interested in right now, but there are two things that we're going to be responsible for creating. So the exam scores class is going to have an array of the different scores that the students achieved, and it's going to contain a method called analyze, which will allow the user to review the scores in different ways. For example, the analyze method could be used to calculate the highest or lowest score, or maybe the average score. The analyze method is going to be a very general do some analysis kind of function, which will take a single parameter that defines what kind of analysis is needed. Now, a starting point for this kind of class might be to say that the calculation required parameter for our analyze method will be a string, and we'll use a switch statement to say if the calculation required is an average, then we'll do this, or if it's the highest value, we'll do something else. Now, I'm showing on screen here what this kind of function might look like. If you're following along, don't bother typing this in because we're not going to be using it. I'm going to suggest an alternative in just a moment. I haven't even started to type in the actual calculations here, but I hope you can see that although this approach will work, if we want to add in further different calculations over time, this switch statement is going to grow and grow, and, well, I think it just feels unpleasant. One of the problems with this is that all of the calculations are going to be contained in this single exam scores class. That's going to make it a potentially very big file, which will become difficult to maintain and debug over time. It will be nicer if we can separate out our analysis calculations into a different part of our code. Well, we can do that using standard object-oriented design. In fact, we'll use what is known as the strategy design pattern. In simple terms, this means that we're going to say that each of the different analysis calculations are going to have the same input and output requirements so that they are interchangeable, and we can select at runtime which of the calculations will get used. We'll separate out each of the calculations into separate classes and pass into this method the actual calculation detail, the relevant class, rather than store the detail within this class. If you want to read up more about this design pattern, then have a look at the Wikipedia webpage, which is on screen right now. If you have done Virtual Pair Programmers Java Fundamentals course, then you should be reasonably comfortable with the code structure we're about to see. If you find the structure confusing, however, then don't worry, because this is a structure we're going to be replacing quite soon with a better Groovy way of programming, and it's enough maybe to realize that this is a structure which is more time-consuming and complex to create than we need when we program in Groovy. So what would this structure look like? Well, we would probably do something like this. We'd say create an interface to define the calculation. Let's call that exam calculation interface, and give that a single method called execute, which takes our array of scores. We can then create some different implementations of this interface, maybe one that calculates the average score, one that calculates the lowest score, and then we can pass instances of these calculations into our analyze method. So this is an object-orientated way of solving the problem. It's how we might have created our code structure if we were using Java, and this is going to be our starting point. I've created a project with some Groovy code in, which does exactly this, and together we're going to enhance this project and see how using functional programming with closures will simplify and shorten our code. So there is a copy of the project I've created in the Practicals and Code folder for this chapter. I'm going to load up this project into Eclipse, and I suggest you do the same. So go into the folder called the starting workspace for this chapter, and locate the folder called exam scores. And you want to copy that and paste it wherever your current workspace is. I've got that here on screen. I'm just pasting in exam scores there. So you want the whole folder, and it's at the same level as your first test and learning Groovy folders that you'll have created if you're following along with me in this course. Once you've copied that in within Eclipse, and I'm just going to close my Learning Groovy project and close all these windows down just to clear down my workspace. So I'm just right clicking on Learning Groovy and I'm going to choose Close Project. And I'm now going to do a new Groovy project. And I'm going to name my project in exactly the same way as the folder was called. That was exam with a capital E and scores with a capital S. Now notice that Eclipse has pointed up here, the wizard will automatically configure the JRE and the project layout based on the existing source. If you see that message, that's fine, you can click on finish. If you don't see that message, then you've either not copied your files into the correct place or you've mistyped your project name. So don't click finish until you can see that message. When you've done that, what we'll see if we go into exam scores and into the SRC folder is that there are two packages called calculator functions and UI. So let's have a look at this project. In the calculator functions package, I've created the interface called exam calculation interface, and this just contains a simple method signature for the execute method, and it expects a set of exam scores, an array of scores. Okay, well, I've created two implementations of this interface, one called average score and one called minimum score. Let's have a look at the average score one. Well, here I hope you can see that I've implemented the exam calculation interface and I provided some code now for my execute method. I'm not too concerned right now what this code does. We actually are going to revisit it a little later on anyway. So for now, let's just understand that we have an interface that defines a calculation and two different classes that implement that interface that carry out or that provide the detail of what that calculation needs to do. Now let's have a look at the UI package. So here's our exam scores class. Here we've got an array of the different scores. It's an array of integers. And we've got our analyze method, which is just going to execute the method on the class that we pass in. Now, this looks like a very simple class. That's because I'm only putting in here the minimum code that we need to learn about closures. In reality, this class would contain much more functionality. Probably the ability to load the exam scores maybe from a database. Perhaps it would have information here about the candidates, the dates of the exams, and so on. I've used a simple array called scores, but in a production system, this would almost certainly be some kind of collection object with lots of supporting code behind it. So in order to use this class, we'll need to create a new instance of either average score or minimum score and pass that into our analyze method. Well, I've done just that in the main class. So down here, we've got a new instance of exam scores. I'm creating a new instance of the average score class, a new instance of the minimum score class, and passing those into the analyze methods to get two different values out, average and lowest, and then I'm just printing those to the console. So I hope what I've done here makes sense. It's pretty standard object-oriented Java-style programming. There's nothing too special going on here. I'm going to save it and run it just to check that that's working. Okay, well, we can see that the average score was 54.17 and the lowest score was 29. Hopefully you've managed to import this project, you've got that working, and you've got the same average score and lowest score printing out. So this code is fine. It's a little unwieldy, but it works. And we've now got a new task. We've been asked to write a new calculation which works out how many of the candidates passed the exam. Now we'll do that by saying how many candidates got a score of 51 or greater. Well, the way we would have to do that right now would be to create a new class that implements exam calculation interface and write the code in there. But this really feels like quite a lot of work. we would have to create a new class, ensure we implement the interface, and, well, over time, the number of these calculator functions classes is going to grow. We might end up with dozens of these, and in reality, they're quite simple classes. Having this structure to enclose what is a maybe 1 or 2 line calculation feels like hard work. Groovy gives us a way to improve on this by saying that our calculation, the piece of functionality, whether that's average, lowest score, or the number of candidates who passed, can be written as a closure, a short anonymous code block that doesn't need to be owned within an object itself. It is an object in its own right, and we can pass that piece of functionality, that calculation, into the analyze method. So let's see how we might do this. Well, the general syntax for a closure is as follows. We'll define a variable, I'm calling my variable in this instance SumClosure, and set it equal to a block of code. Within the curly brackets that define the block of code, we'll start by listing the variables that the code block can take as its parameters. These are pretty much the equivalent to a standard set of method parameters. And then we'll put in what looks like an arrow. It's made up of a hyphen and a greater than sign, and then our code can follow. For example, if we wanted to write a code block which would add 2 numbers together, it would look something like this. So I've defined a variable called addNums. I've set it equal to a code block which takes 2 parameters called firstNum and secondNum, and then the code simply adds those 2 together. You might remember from the chapter on methods that this is equivalent to saying return first num plus second num. The keyword return is optional when it's on the final line of code, and that's the same here. So this addNums closure is pretty much the same thing as this addNumbers method. Here I've said the method takes 2 parameters and we're returning the first plus the second. These 2 things do the same thing, but the addNumbers version is a method that has to live within a class, and we have to instantiate the class before we can use it. The addNums version is a closure. It's an object in its own right, and we can pass that object around our code. Let's, as an example then, create a closure which tells us the score that the very first candidate got. So let's go back into the code, and because we're going to break this bit of code here, I'm going to comment it out for the moment, and we'll come back and fix that shortly. So what I want to do now is create a new closure, which is going to calculate the first score. It's going to tell us what was the score of the first candidate in the array. So we'll define a new variable, we'll do def, and then I want to call the variable something. Let's call it first score. And I'm going to set that equal to a code block. Well, the first thing I need is any parameters the code block's going to take. Well, it's going to take the full array of scores, and we need to give that a name. Let's just call it scores. Okay, we then want our arrow symbol that's made up of a hyphen and a greater than sign, and we can then continue with the implementation of our method, what we want the closure, the function to do. Well, I just want to return the first value from the array, so I can put in simply scores in square brackets 0. Let's just pull out the item in position 0. So what I've got here is a closure. It's a code block equivalent really to a method. The method would be saying take a array and pull out the first item. But because this is a closure, we can pass this to another function. So let's jump across to the exam scores class. Now at the moment, the analyze method is expecting some kind of calculation. I'm going to rename this to closure just to be clear that it's a closure we're passing in here. This can be called anything. I could leave it as calculation, but I think it'll make more sense if I call it a closure. So I'm saying that our analyze method is now going to expect a code block to be passed in. And what's it going to do with it? Well, it's just going to run it. We've no longer got a .execute method. We're just going to run our closure. and we're going to pass into it that array of scores. Now, I'll run this in a moment, but let's just first recap what's going on. From our main method, I've declared a new code block. This code block contains a piece of functionality which can be run, which expects an array and returns the first item. Our analyze method is going to run that functionality passing in the array. So in order to run this, in order to test it works, all I'll need to do is to call my analyze method passing in my first score closure. So let's do that. Let's store the results first as, I'm just going to call it first. So we'll do def first equals, well, I want my exam scores class. I'm going to call the analyze method, and this is expecting a closure, and we've got a closure. It's called first score. Let's print out what the first score was. The first score was $first, and let me save and run that. Okay, the first score was 72. That worked. Now, that's actually then done the job for us. We didn't need to go and create a new class. We didn't need to implement this interface. What we've managed to do, and I know I'm going on and on about this point, but it is a bit of a different mindset. It is a different way of thinking to standard object-oriented programming, is we have written some code that takes a block of code and executes it. Let's have a go at doing the same thing now with the average score. So I'm going to create a new closure, this time that calculates the average score. So let's do that here. I'll make this window a bit bigger. So I'm going to create the closure. I'll call it average score. So we'll do def average score. This is a closure, so it's equal to a block of code. It's a piece of functionality. I wanted to take a single parameter again, which will be the list of scores. So we'll do that here. And then, well, what is the functionality? We'll separate the parameters from the functionality with our arrow, our hyphen and our greater than. And, well, I've written the functionality already in my average score class. So what I'm going to do is copy it from here and edit it. So I'm copying everything within the execute method. And I'll go back now to my main class and paste this in. Okay, well, let's run through this. We've got a total that we set to 0. That's fine. We then loop through all of our scores and add the current score to our total, and then divide the total by the number of scores to get the average. Well, the only thing I need to do here is change this reference to exam scores to the variable name that we're using here, which is scores. So let's just do that. It appears 3 times. I'll just change all 3. Okay, so this right now is a piece of functionality. It's a bit like a method. We're saying that in this method, in this piece of functionality, we're going to take an array, we're going to loop through the array, adding up the values, and then work out what the average is right at the end. Right now, this average score closure, this piece of functionality, knows nothing about the exam scores class. It knows nothing about the data that's going to be passed into it. It's just a piece of functionality that's floating around. It's free for us to use. So let's go and use it. Let's set our average variable. I can uncomment this line now to be calling the analyze function, and this time we're passing in, rather than a new instance of our average score class, just our closure, our piece of functionality called average score. I'll just copy and paste that down there. And now I can uncomment this line as well and print out what the average score was. So let's save and run that to check that works. Okay, well, there we go. Our average score was 54. Now, I'd like to suggest that you have a go at doing exactly the same thing with the lowest score. We're going to create a new closure in our main method called lowest score. You can use the existing code that we wrote in the lowest score class to use as the basis for the code within our closure, and then we'll execute it. So pause the video now, have a go at doing that, and then when you have had a go, press resume. I'll do the same thing, and we can compare our results. Okay, so I hope you did have a go at doing that. I'll do that now as well. So I'm creating a new closure. I'm going to call that one lowest score. And I'm setting that equal to a piece of functionality, so it's defined with a code block. Again, we want a single parameter, which is the array of scores. I'll put my arrow in to separate the list of parameters from the functionality. And again, I'm going to go to the class that we wrote earlier to get the existing code, and I'll edit it. So I'm copying all of that back in my main class. I'll paste that in here. And actually, the only thing I need to do is change the value of exam scores to scores, which is the name of the parameter that I provide into this piece of functionality. So we'll change all three of those, and that should work. While I'm here, let's just check what's happening in this method. We actually start by assuming the lowest score is 100, and then loop through each of the scores, checking if the particular score in turn is lower than our current lowest score, and if it is, we swap our lowest score and make it equal to that. So again, reasonably simple, straightforward code. Well, I can now uncomment the rest of this code here, so we can find out what our lowest score was and print it out. The only thing I need to change is that when we call exam scores, we're now going to use our lowest score closure. Okay, let's save and run that and check that works. There we go, our lowest score was 29. So now we don't need the interface or these classes. We can create these closures as blocks of code and pass them directly into the method. I won't bother deleting these three, but you could do. We're not going to need them anymore. Before we go any further, let's have another look at the syntax for closures once again. The syntax we've just seen and used is valid when there's one or more parameters to the closure. When there are no parameters, we can just type the code straight in. You might remember we wrote a closure like this. Here, print line hello Matt doesn't require any parameters, so we didn't need to declare any. When we don't require any parameters, we don't include the arrow, the hyphen and the greater than sign to separate the list of parameters with our code. We also saw earlier in the course that when we create a closure that takes one parameter only, this parameter has a default name of it. So again, this is it. It's not short for iterate or anything else. It's just a default name when there is one parameter only. We can explicitly name that parameter if we want to. So for example, these two lines here will do exactly the same thing. In the second version, we've given the parameter a name called counter. In the first version, we haven't, so the default name of it is used. Well, using this, there's actually an opportunity to improve the code we've been writing a little bit further. If we go to these two closures, our average score and our lowest score closure, you can see that we're creating loops to loop through the different items in the array. Well, arrays have a .each method, and the .each method takes a closure. So we can shorten this code by using that version to loop through the array. Let's do it first with the average score. So we're going to first say there's a variable called total with a value of 0. That's fine. Now we're going to loop through our array, and the array is called scores. So it's going to be scores.each, and that's going to expect a closure. Now the closure is going to have one parameter, and that's going to be the item in the array, the different score. I'm going to name that parameter. I'm going to call it score. And then I'm going to say, well, what are we going to do with that score? Well, we're going to add it to our total. So I'm going to say total plus equals the score. That replaces all of this section here. So I can remove that. And in fact, all of this could go on one line. It could be made really neat. If I do that, and now we can see we've simplified, we've made our code much shorter. Actually, because there's only one parameter, I didn't need to name it. I could have used the default name of it. So if I make it like that, it's going to be scores.each total plus equals it. Now, that feels like it might be a little bit of a jump, But have a look at this. Def average score is a closure which takes an array of scores, and what we do is we loop through each of those scores and add each item, that's the it, to the total. And then we do our little averaging at the bottom. What we've got here is 4 lines of code that effectively does the same as the whole of that class. We can do exactly the same thing with the lowest score, of course. Take scores, take the array, call the .each method, and the closure that's going to be expected is simply going to be to, well, we've got the code really down here. We can say, let's copy and paste this up there. We can say if it, rather than the individual item, is less than our lowest figure, we'll make our lowest figure equal to it. I'll remove the original loop, and let's just save it and check that code runs and works. There we go. Our average score is 54, our lowest score was 29. So I think we've ended up, by using closures rather than those interfaces and classes, with some much shorter and more efficient looking code. I think we're now ready to try and create that new piece of functionality, finding out how many of our students passed the exam. I'm going to suggest that you pause the video now and have a go at doing this. The task is to create a new closure which will be very similar to the ones we have here, but this time we want to know how many of the students scored greater than 50. So pause the video, give this a go. When you've had a go, press resume and we can compare results. So I hope you had a go at that. Let's do it together now. So I'm going to create a new closure. I'll do that here. I'll call this one passed. That's for the students who passed the exam. And I'm going to say it's a code block that again takes an array of scores. And well, what are we going to do? We're going to count up how many did pass. So we need some kind of internal variable. I'm just going to call this one result. So we'll say the number of people who passed is our result, and initially that's going to be 0. We then want to loop through each of the scores. And what are we going to do? Well, we're going to check if the individual score is greater than 50. So I want to know if the individual score, that's it, is greater than 50. If it is, then what we'll do is we'll increase our result. So that will be result plus plus. Okay, I think that's going to do it. All we need to do now at the end of this is return the value of result. So I think that should do it. Let's just put in a final couple of lines to run that and print it out. We'll do def passed number, I'll have to call it something different, is going to be equal to exam scores dot analyze, and this time we're passing in the closure called passed, and we'll print out, well, let's start with the number who passed, do dollars passed number, and then passed the exam. Let's save and run that. And there we go. 8 of our students passed the exam. I can't remember how many students there were. I don't know if that's good or bad, but we've shown that we were able to very quickly and very easily define a new piece of calculation, a new piece of functionality, and pass that across as though it's an object to another method somewhere else in our application and retrieve a result. I want to just finish this section by mentioning that in the example we have been working through, we have actually written closures in 2 different ways. In this section of our code here, we created a closure called lowest score. Because we created the closure and assigned it to a variable, that's the variable called lowest score, we can reuse this closure as many times as we like. If we had another class elsewhere in our application that could also take a similar closure, well, then we could apply lowest score to that class and those methods as well. Within this lowest score closure, however, we created a second closure here with our .each method. This closure, which starts here and ends there, actually just looks very much like a code block that you might find within a typical for loop. And because we haven't assigned this closure to a variable, it's not going to be reusable. We've written it in line within our code. Now, I'm only pointing this out because creating closures in line like this is actually far more common, and we'll see lots of examples of that throughout the rest of this course. Let's create one further exam scores analysis routine, but this time we'll do it with an inline closure. It'll be quite simple this time. I just want to know how many candidates took the exam. So we'll go to the bottom of our code, and I'll do that with def number of candidates, and I'm going to set that equal to, I'm calling it inline, so I want my class, which is exam scores, then the method, which is analyze, and this method requires a closure, and that's going to be in curly brackets. Well, it has one parameter, which is the scores, my arrow, and then I want to just pull out how many items there are in the array, so I can do that by calling the dot size method. So I can do scores dot size. Okay, I'll need my closing curly brackets. So I've written it all on one line here, which is a very typical way of writing this kind of code. Let's print out the results. So we'll say there were dollars number of candidates, and then the word candidates. Okay, let's save and print that to check that's worked. 17 candidates, that looks good. Now, when we call a closure inline like this, Groovy gives us a slightly neater syntax that we can use. And that is that we don't need the round brackets around the closure. I can take those off and just leave in the curly brackets that define the start and end of the code block. Now, that should make sense. We've seen earlier in this course that when you call a method with a single parameter, the brackets are optional. And that's the same thing here. It just looks a little unusual because the parameter is a code block this time. However, Groovy actually goes a little further. Suppose we had a method which took two parameters, of which one was a closure. I'm going to go back into my exam scores class and create a method like that. So I'll create a second method here called analyze with pass mark, where we'll pass in the mark that would be required to have passed the exam along with some kind of calculation, which is the closure. So we'll call this one def analyze with pass mark. And I'm going to provide two parameters to this method, which is the passing mark and a closure. Okay, well, within the method, I'm going to do something with that pass mark. I'd probably say pull out all of the scores from the array that were above that pass mark and then use that array, that new array with the lower number of scores in to do the calculation. I'm not going to bother writing that. Let's just put some remark in to say that's what we do. So I'll put in do something here with pass mark. And then we'll execute the closure. So I'll just put in the closure executing on the scores array. So we've got here an outline of a method that takes two parameters, of which one is probably going to be an integer and the second is the closure. Now, when I call that method, and I'll do that now from the main class, well, let's do def, I'm going to call this test pass mark. And I'm going to set that equal to exam scores dot analyze. Well, I've got two parameters this time, which is going to be the pass mark. Let's make that 50. And my closure, well, I'm just going to copy, in fact, the closure I've got here. Like so. The point about this alternative syntax where we don't need to put the closure in brackets is that for this line, I can close my brackets after this parameter and leave the closure outside the brackets. I think this really aids readability. You can only do this when the closure is the final parameter and when there is only one closure in the method call. So this could read test pass mark equals whatever the method is in brackets all the other parameters separated by commas, just as you would with any method call, and then outside the brackets at the end, the closure. We have actually seen and used this syntax in the chapter on ranges. You might remember that If we wanted to step through a range using the step method, for example, let's print out all the even numbers between 20 and 30, I'd be doing something like, well, let's have a range 20 dot dot 30, and I want to call dot step. And dot step is a method which takes two parameters. The first parameter is the number of points we want to step through. So that's going to be 2 in this example because I want every other number. And the second parameter is the closure. And I can provide that outside the brackets. So I can do in this example, print line it. Before I can run this, I realize I'm calling here my analyze method. This should of course be the new analyze with pass mark. So I'll just correct that. And if I run this now, there we go. So we've got our stepping out there. Okay, I didn't print out anything from the analyze with pass mark, but you can see that this is a nice syntax that works well. It's very easy to read. So that covers the basics of closures. In this chapter, we learned what a closure is, and we saw the syntax for writing closures. We looked at the basics of functional programming and how closures can act as a building block within our code. And we finished the chapter looking at how to write inline closures. We'll be using closures in the next 2 chapters on collections, and we'll be coming back to closures again later in this course. But for now, I'll see you in chapter 12, where we'll be working with lists.